Next up, triangles and trapezoids. The reason why I did parallelograms, which are a less common shape than triangles, first is because parallelograms are sort of the gateway triangle, the gateway shape. If you know that the area of a triangle is base times height of the area of a parallelogram, did I say parallelogram? I hope I did. Then let's look at the area of a triangle. Here's a nice triangle, nothing wrong with this. Here's the trick. I want to know what the area of this triangle is. First thing I do, I make an exact copy of it. Bang! There's an exact copy of it in a slightly different color. What I do is I take the second triangle and I rotate it 180 degrees. Now remember, these two are basically the same triangle, they have the same area, but I can slide this one over, line it up, it will line up exactly right because, you know, that was the same side length, and the end result is, ta-da, a parallelogram. Two copies of a triangle makes a parallelogram. What's the base of the parallelogram? The same as the base of the triangle. What's the height of the parallelogram? The same as the height of the triangle. Therefore, this combined shape has an area of base times height. But the triangle we want is just half of it. And therefore, the area of a triangle with a base of b and a height of h is 1/2 base times height. Very neat, very neat. A trapezoid. A trapezoid is a shape, it's a little bit like a parallelogram, but it has exactly one set of parallel lines, and the other set of lines are not parallel. So sort of the poster child of a trapezoid is something that looks like this. And what we say is that it has two bases, base 1 and base 2, and it also has a vertical height. Let's let's do the exact same trick that we just did. How do we do this? Keep the height. I'll call this base 1. I'll just call it B1. I'm going to have a B2 somewhere. How do I do this? I am going to extend the line like this. And that is my trapezoid. Let me make it even more clear that the two ends are different. So these lines are parallel, and they don't even have to have the same length. Anyway, this has a base of base 1 and base 2. What do? I do the same thing. I cut this, I paste it, I make another one. I do a thing called make it so that I can fill it in, and now it does. The magic of a computer. Anyway, we can do the exact same trick. We can rotate. So I want to know the area of this trapezoid. I have no idea what the area of the trapezoid is, but I know that this trapezoid is the exact same copy as this trapezoid. If I rotate it 180 degrees, these sides will line up just perfectly, and the end result, did I do it perfectly? I am less than perfect. I hang my head in shame. The end result is one gigantic parallelogram. Again, the gateway shape. Parallelogram, where the combined base is B1 plus B2, because what had been the top is now added to the bottom. B1 plus B2 by H. What is the full area of this? The full area of this is B1 plus B2 times H. But we only want one trapezoid. If two trapezoids have this as their area, then one trapezoid has an area of 1/2 B1 plus B2 times H. And that consists of all the formulas I want you to know. I want you to know that formula. I want you to know the area of a triangle is 1/2 base times height. I want you to know that the area of a parallelogram is just base times height. I want you to know that the area of a rectangle is also base times height, and that's pretty much it. I'm sorry I'm not teaching more today, but go have fun.